In the last video, we did something and then it disappeared. We went inside a container, we changed a web page, we refreshed the browser and it worked. Then we deleted the container, made a new one, and our change was gone. And I told you that was normal. That is how containers work. But then the obvious question is okay, so how do I make something that stays? How do I make my own thing? Today, we answer that. Today, you are going to build your own image, not Nginx, not somebody else's, but yours, with your own application inside it. And by the end, you will delete the container, make a new one, and your work will still be there. So, without wasting any further time, let's build it. Last time, I said an image is like a recipe, and a container is like a plate of food. So far, we have only used recipes that other people wrote. Nginx is somebody else's recipe. We just cooked it. Today, we write our own recipe. And to write a recipe, you need a piece of paper to write it on. In Docker, that piece of paper is a file called a Dockerfile. A Dockerfile is just a text file. That is all it is. And there is no magic. It is a plain text file where you write down step by step how to build your image. The instructions are like this: start with Python, copy my files in, install what I need, run this command. That is it. Instructions in order, top to bottom. So now we have three things, and I want you to see how they connect. You write a Docker file. That is your handwriting in paper. Then you build it. Building turns your handwritten notes into proper finished recipe card. That finished card is the image. Then you run it and you get a container, the plate of food. So write, build, run. Remember those three words. That is the whole video. Before we write the Docker file, let's make a small app, a real one. Let's make a folder. Now let's open it in VS Code. If that command does not work for you, no problem. Just open VS Code normally and open this folder. Or use any editor you like. It does not matter. Now let's make our app. New file, call it app.py. Let me explain this because some of you are not Python people and that is completely fine. You do not need to know Python for this series. Flask is a small tool for making websites in Python. Very small, very popular. This app equals to Flask creates our web page. At the rate app.route, this means when somebody opens the main page, run the function below. And the function just returns some HTML, a heading and a line of text. That is the page. The last two lines start the web server on port 5000. Now, look at this bit carefully. This looks like a strange number and it is very easy to ignore. Do not ignore it. This one thing breaks more beginner Docker apps than anything else. Here is what it means in simple words. 0.0.0.0 means accept visitors from outside. If instead you write 127.0.0.1, that means only accept visitors from inside this same machine. Now, think about our container. The web server is inside the container. Your browser is outside on your machine. Those are two different places. So if you say 127.0.0.1, the server only listens to people already inside the container. Your browser is outside, so it gets refused. And the cruel part is Docker PS will still say the container is up. Everything will look fine, but the browser will just show nothing. So if that ever happens to you, like the container is up, page does not load, then check this line first. 9 times out of 10, this is the main problem. Okay, one more file. Our app needs Flask installed. So we write down what we need in a file called requirements.txt. Here we use Flask double equals to 3.1.0. That is a list of what my app needs. Just one thing today. And notice I wrote the exact version 3.1.0. Always write the version. If you do not, you might get a different version next month and your app breaks for no reason you can see. Now, let's try to run this app the normal way without Docker. And it fails. No module named Flask. Now stay with me because this error is the whole reason why Docker exists. My machine has Python, but it does not have Flask, so the app does not run. To fix it the old way, I would have to install Flask on my machine. And then, if I send this project to you, it fails on your machine too. And you have to install Flask as well. And maybe you have a different Python version and it behaves differently. And maybe your teammate is on Windows and something else goes wrong. This is the famous problem, but it works on my machine. Every developer has said that sentence, usually while somebody is angry at them. Docker's answer is simple and a bit bold. Instead of shipping just your code and hoping the other person's computer is set up right, you ship the whole computer. Python, Flask, your code, everything in one box. That box is your image. So let's build it. Now let's write our Docker file. See carefully what I have written. The Docker file name should be just like this. Remember, there is no extension to it at all. No txt, not py, no any other extension. Just pure Docker file. And also see that I have only used capital D and there is no other capital letter in it. And also there is no space between Docker and file. So remember this always. This is how you name it. Now let's write it one line at a time. I will explain each line before we write the next one, and I'll try to be as slow as possible. So let's write our first line. Let's type from Python colon the version of Python we are installing. For now, I am installing 3.12-slim. From is always the first line of any Docker file. It means start from this. You almost never build an image from nothing. You start from an image somebody already made and you add your stuff on top. Here we start from Python column 3.12-slim. That is an official image that already has Python 3.12 installed and working. The word slim means it is a smaller version. It has a Python but not a lot of extra stuff we do not need. Remember, smaller is always better because it's faster to download. So, line 1 means give me a small Linux machine that already has Python on it. Now let's move to next line. Type workdir space slash app. Workdir means work inside this folder from now on. It is the same as typing cd in your terminal. Every command after this line happens inside slash app. And if the folder does not exist, Docker creates it for you. So we do not need to make it first. You might be thinking, why bother? Because without it, your files land in the root folder and it will be mixed in with all the Linux system folders. It will be messy. This keeps our stuff in one clean place. Now let's move to our next line. Write copy space dot space dot. Copy moves file from your Mac into the image. Now, there are two dots and they mean different things. This confuses people. So let's be clear. The first dot means everything in my current folder on my Mac. The second dot means put it in the current folder inside the image. And what is the current folder inside the image? It's slash app because we just said that with WORKDIR. So copy everything from my folder into slash app inside the image. That takes app.py and requirements.txt and puts them inside. Now let's move to the next line. Type run space pip space install space hyphen no hyphen cache hyphen dir space hyphen r space requirements.txt. Run means run this command while building the image. This is important. So let me be very clear about the timing. Run happens while you are building. Once, not when the container starts during the build. So this installs Flask right there inside the image permanently. It becomes part of the image. Anyone who uses this image already has Flask. They do not install anything. Pip install -r requirements.txt is the normal Python way to install from the list we wrote. And -no cache dir just tells pip not to keep the downloaded copies afterwards. We do not need them. And it makes the image smaller. Now let's move to the next line. Type expose space 5000. Now I have to be honest with you about this line because a lot of tutorials get it wrong. Expose does not actually open anything. It does nothing to your network, nothing at all. It is a note, a label. It is documentation for humans saying, hey, this app uses port 5000. The thing that actually opens the door is -p, which we use later when we run the container. That is the real one. You met it in episode 1. So the question is, why write expose? Because when somebody else picks up your image, they can look at it and see which port to use. It is being polite. Keep it, but know that it is a note, not an action. Now let's move to the next line. Type cmd and under the brackets type python, comma app.py. CMD is the last line and it means when a container starts from this image, run this. Compare it with run for a second because this is the pair people mix up. Run happens while building once. CMD happens when the container starts every time. So, run installed Flask into the image. CMD starts our app when someone runs a container. And notice the strange way it is written. Square brackets, each word in quotes, separated by commas. That is just how Docker likes it. It is a list, the command, then each part of it. You could write it as plain text and it would mostly work, but this way is the correct way. So let's do it right from day one. And that is our whole Docker file. 6 lines. Read it top to bottom like a recipe. Start with Python, go into the app folder, copy my files in, install what I need. Note that we use port 5000. Run the app. That is it. That is a Docker file. Now we build. So let's go to our terminal and type a command. Docker build -t my app and a dot at the end. Let me break it down for you. Docker build, take a Docker file and turn it into an image. -t space my app. -t means tag, which is really just a fancy word for name. We are naming our image my app. Without this, your image gets no name and you have to use a long ugly ID. So remember, always give it a name. Dot is the last thing, and this one matters. The dot says the Docker file is in this folder and the files I want to copy are here too. This is why you must be inside your project folder when you run this. That dot means here. A lot of people forget the dot and get an error. Press enter. Now watch this. This is genuinely nice to watch. See how it goes step by step. It is doing exactly what we wrote. It is pulling the Python image, that is our from line. Now it is setting the work folder. It is copying our files in, and here, look, it is installing Flask. You can see pip downloading it. That is our run line happening right now inside the image. Done. Took about some seconds. Now let's look at our images. Let's run Docker images. There it is, my app, sitting right next to Nginx. Your image next to an image used by millions of websites. Docker does not treat them differently. They are the same kind of thing now. You just build that. Now let's cook it. Let's run Docker run -d -p 8080 colon 5000 hyphen name my web my app. You have seen most of this before in episode 1. Same command. But look carefully at the ports because they are different this time. -p 8080 colon 5000. In episode 1 it was 8080 colon 80. Now it is 8080 colon 5000. Remember the rule? Left is my computer, right is inside the container. Inside the container, our Flask app listens to 5000. We wrote that in app.py. So the right side is 5000. On my machine, I want to use 8080 in my browser. So the left side is 8080. They do not have to match. They almost never match in real life. Left is outside, right is inside. Now let's run Docker ps. It's running. This is our image, our container. Let's open it. That is your app, your code running inside an image that you built. Nobody had to install Python. Nobody had to install Flask. It is all inside the box. One more useful thing. Let's look at what our app is saying. Let's type docker logs myweb. This shows you everything the app printed. You can see Flask starting up and you can see it received our request from the browser. Docker logs is going to be your best friend. Whenever something is not working, this is the first place you look. Remember it. Now, let's answer the question from episode 1. Let's prove that our work stays this time. Let's change our page. I changed one line. Save it. Now refresh the browser. Nothing happened. Still the old page. And that is correct. That is not a bug. Why? Because the container is running the image. And the image was built before we made this change. The image does not know about our edit. Our edit is sitting on our Mac in a file outside the container. So, when you change your code, you have to rebuild. Let's type docker build -t my app space dot. Notice that this was quicker. Docker remembered some of the work from last time. There is a whole video coming on why, because that speed is worth understanding. That is episode 3. Now we have a new image, but our old container is still running the old one. So let's replace it. Let's type docker rm -f myweb. Now let's type docker run -d -p 8080 column 5000 name myweb my app. There is our change. So the rhythm when you are working is edit, build, run. Edit your code, rebuild the image, run a new container. You will do that 100 times. It becomes muscle memory. Now, the real test. The thing episode 1 could not do. Let's completely delete this container. Let's type docker rm -f myweb. That is gone. And now we create a new one. Docker run -d -p 8080 colon 5000 name. Let's name it myweb2 and my app. Still there. Last episode, we deleted the container and our work vanished. This time, we deleted the container and our work survived. Because this time, the change is in the image, not the container. Last time, we changed the plate of food. This time, we changed the recipe. And that is the whole difference. You can delete that container 100 times. Every new one will have your app in it. You could send this message to a friend on Windows and it would run exactly the same. That is what you just built. Now let's clean up. And our image is still there. Keep that one. We are going to use it again in the next videos. If you ever want to delete an image, the command is docker rmi. That is rm for remove plus I for image. But do not run that now. We need it. Quick recap. A Docker file is a plain text file with instructions. 6 instructions today. From start from this, WORKDIR, work in this folder, copy, bring my files in, run, do this while building, expose, a note about the port. It does not actually open anything. CMD, run this when the container starts. The big one to remember. Run happens while building. CMD happens when starting. Docker build -t name dot turns your file into an image. Do not forget the dot. When you change your code, you must rebuild. Remember, edit, build, run. And remember to put host equals to 0000 in your app, otherwise your browser will never reach it. Next video, we look at something you just saw and probably did not notice. Our second build was faster than the first one, a lot faster. That is Docker caching. And once you understand it, you can take a build that takes 2 minutes and make it take 2 seconds. It is one of those things that separates people who use Docker from people who actually understand it. That is episode 3. If this helped, subscribe. And if any line of that Docker file is confusing to you, ask me in the comments. I answer everyone. See you in the next one.